Hello everyone, this is Renifani Shekhar from Global Customer Support. In today's video, we are going to see the Object API used in PIM. Agenda of today's video is, we'll see the introduction, then the prerequisites required, and the available REST Object API, which are REST Object API Read versions 1 and 2, and REST Object API Write, followed by a demo and then the summary of this overall presentation. Now let's start with the introduction of Object API in PIM. So Object APIs in general are used to provide the requested or the basic information about the client objects. Here it provides a canonical REST API for entity items. Object API is introduced with PIM version 10.1, which includes only the Read Object API. An optimized version of the Read Object API and a new Write Object API is introduced with PIM version 10.5. All CRUD operations, create, read, update, and delete operations for all repository-based entities can be performed using Object API. Let's now move on to the prerequisites to use the Object API. All REST API requests necessitate authentication. Access to product manager's resources can't be anonymous. Two REST API versions are accessible, version 1.0 and version 2.0. It is recommended to use the latest version as older ones could be phased out. The Object API adheres to the Open API standard 3.0.3 across its operations. Authenticated users must possess entity and field permissions to access requested information. For testing the Object API, set up Postman as follows. During the demo, we'll provide further guidance on using the Postman tool to interact with the Object API. For inclusion in the Object API's data elements, sub-entities or fields must meet these criteria. The entity or field must be active within the repository. Supports audit trail must be set to true for the entity or field in the repository. Fields designated as password fields in the repository cannot be included. Qualifications should be editable within the repository. These criteria ensure the suitability of sub-entities and fields for integration into the Object API's data structure. Now let's move on to REST Object API Read version 1.0. This Object API is designed to provide efficient usage for both single and multiple items, enabling retrieval of comprehensive hierarchical data for these items. When making read requests to the API for single items, the URL pattern is /object/entity identifier/entity item, and the method used is get. This API is optimized to handle requests for a single item, ensuring efficient data retrieval. For multiple items introduced in version 10.1.0, hotfix 2 and onwards, due to query parameter size limitations, this API has been structured to use HTTP POST requests for querying multiple items. This design choice helps overcome the limitations posed by query parameter lengths. In summary, the Object API is tailored to cater to both individual and batched requests for items. In order to use the version 1 of the REST Object API for reading data, two conditions need to be met. The entity or field should have support service API set to true in the repository. The entity or field must have a short identifier specified in the repository. During the upcoming demo, we will provide an overview of how the version 1 REST Object API read works, along with illustrative examples to showcase its functionality. Now let's move on to REST Object API read version 2. In the 10.5 release, a new enhancement is introduced. REST Object API Read version 2. In version 2 of the Object Read API, a new parameter called Include IDs is introduced. The response payload is streamlined, eliminating the need for the extra current element. For fields or entities supported by Object API version 2, the supports Object API flag in the repository is now utilized. In our upcoming demo, we will provide an overview of how version 2 of the REST Object API read functions. We will also present examples to illustrate the changes and improvements this version brings. Now let's move on to REST Object API Write. This API offers create, update, and delete actions for objects. When deleting sub-entities, it's treated as an object update. Update calls verify if the item exists. If not, they create it. Request syntax for creating an object includes post method, and the URL pattern is /object/entity identifier. And for update object, it's put method, and the URL pattern is /object/entity identifier/entity item. Delete object. For bulk deletion of multiple items, it's recommended to use the list API. Using the object API's delete method for numerous items can strain the system. Opt for the REST list API delete for better efficiency. During our forthcoming demo, we'll provide an in-depth explanation of the REST Object API write functionality. The session will also include illustrative examples to showcase how these actions work. Now let's begin with the demo part. Before moving on with Object API examples, let us see the properties to be set or available in repository for the entity to be fetched using Object API. Let's see for one entity, which is article item under custom section. Here the supports audit trail, supports Object API, supports service API are all set to true. Also it has a short identifier, which is article. The short identifier is unique within its parent entity only. The standard repository already contains a short identifier for all fields and enabled qualifications. With 10.5, supports Object API flag is included in the repository. This is the repository of 10.5 hotfix 1 version. Now let's see for one of the field under article item entity. Article.supplier AID, which is the item number. Here you can see the supports audit trail, supports Object API, supports service API are all set to true. Also it has a short identifier, which is identifier, and then it is not a password enabled field. This has been set to false. Now let's move on with Object API examples. Have the postman setup ready. The user authenticated by PIM has to be provided in the authorization tab. Let's start with the Object API info. The method used here is get. The URL pattern is /object/entity identifier/info. Since it's a 2 PPD data model, the entity identifier involved here are article and product 2G. Accept header allowed or used generally is application JSON, and if multiple headers are defined, they will be evaluated by their order. The wildcard media type / will result in XML. The default accept header is application/XML. Now let's fire this Object API info call. Here you can see the output of the Object API info. It provides the description of the REST call action and its responses. The response provides the available REST Object API, which are read and write. The PIM client version used here is 10.5, so you can see the responses of the write API call. And also it provides information on the accept headers, which is allowed here. Now let's move on with the read Object API version 1. The read request allowed here are for single item and multiple items. Now let's start with the single item. The method used here is get, and the URL pattern is /object/entity identifier/entity item. The accept header of this Object API is application/JSON, and the default accept header is application/XML. The accept header allowed here is application/JSON, or the default one, which is application/XML. The get Object API call includes the URL pattern /object/article, which is the entity identifier/entity item. 1/1000 depicts the entity item, which is article ID at the rate of catalog ID. Since we haven't provided any query parameters here, all the available data of this particular object would be returned. Let's now fire this Object API call. So here the status 200 OK is returned, which means we have received a response of this object. In case if the user doesn't have any required permissions, read permission, 403 forbidden code would be written. If the object is not found, then 404 not found code would be written. In case of internal server error, 500 written code would be written. Here in the response, the entity item syntax includes the entity ID, internal ID, and the external ID attributes. All the meta attributes are prefixed with an underscore. Underscore entity provides the root entity identifier. Underscore entity item provides the entity item in the entity item syntax. Underscore revision provides the revision of the data. Underscore data provides the actual entity items data. Underscore current provides the current value of the field. Here it provides the item number of this particular article. If we go through the data which has been retrieved, we could see the supplier details and the short description, long description, and the media assert which is linked to this particular object. Enumeration fields underscore key always holds the unique key of the enumeration entry. Underscore code provides the external code of the enumeration entry if the entry has 1 and it differs from the key. The response also includes the creation date, creation user, modification date, and modification user details. Timestamp and date is of ISO 8601 standard. Now let's see an Object API example with a query parameter included. With Read Object API version 1.0, there are 4 query parameters included, which are entity filter, qualification filter, revision, and include labels. Now let's fire the Object API call with the entity filter article lang. This will be providing the subentity details of the object in all the available languages. If you can see the output here, it has the response in English and in Chinese language. Let me add the qualification filter, which is language in English. Now only the short description and long description in English language is retrieved. Now let's move on to Read Object API version 2.0 example. In version 2.0, a new parameter include IDs is included in the query parameter, and a streamlined response payload which no longer contains the extra underscore current element can be found. Here if you see, it provides all the available data under the data syntax, and it doesn't have underscore current element in the response received. Now let's add some query parameters over this version 2.0 Object API call. Here if you can see, it has provided the short and long description in the English language. So far we have seen the Object API request for retrieving single item information. Now let's see the Object API request for multiple item retrieval. The method used here is post, and the URL pattern is /object/article/by items with a list of entities which has to be part of the Object API response. Now let's try for version Read Object API version 1.0. The content type has to be this, and the accept header has to be application/JSON or the default one, which is application/XML. Let us fire this API call. Here you can find the data of both the items retrieved over here. Since it is version 1.0, you can find the current underscore current element being included here. Now let's try the same for version 2.0. So this has retrieved the information of both the items, but here the underscore current element will not be found. Now let's try adding few query parameter. With Read Object API version 2.0, a new parameter include IDs is included. If it is set to false, the payload avoids to contain any internal ID of the object, and if it is set to true, then the internal IDs would be included. By default it is set to false. Now let me try adding the value true for this parameter. Here you can find internal ID is being included with the REST API response, where we have used the Object API version 2.0. Now let's move on to Write Object API, which is introduced with PIM version 10.5. It provides the create, update, and delete calls for objects. Now let's see the Create Object API. The method used here is post, and the URL pattern is /object/entity identifier. The content type recommended here is application/JSON or the default application/XML. The accept header allowed here is application/JSON or the default application/XML. The query parameter included in the which can be included in the create object APIs or update if exist, which is a Boolean data type. If it is set to true, then the existing entity item will be updated. Container can also be provided, which is nothing but the catalog in which the item has to be created. Let me just fire this API call. Here I haven't provided any container or any other query parameter. It has provided a response status 201 created, which means an item is created successfully in the master catalog. 200 OK written code shows the entity item has been updated successfully. 400 bad request shows the entity item has not been created or updated. 403 forbidden if the user has no create permission for that entity. 404 not found if the entity could not be found. 429 too many requests if the number of concurrent write calls is too high. 500 written code would be written if the entity item has not been created or updated due to unexpected server error. Here the item is created in the master catalog. We can also check the data of this particular article using the read API call. Here we can see the article has been created in master. We can find the creation date and the creation user details. Now let's move on to update object API. The method used here is put. The URL pattern is /object/entity identifier, which is article here, /entity item, which is article ID at the rate of catalog ID. The accept and content type headers recommended here are application/JSON and application/XML, which is the default one. The query parameters included here is create if missing, which can be included here is create if missing, which is a Boolean data type. By default its value is true, so based on this parameter a missing entity item will be created with a given identifier. In order for this to work, we must be providing the external ID for the entity item parameter. Now let's fire this example object API call. It has written 200 OK, which means the entity item has been updated. Similar to create object API, the written codes will be written. Adding to that, 503 service unavailable written code will be written in case the execution has been interrupted or cancelled unexpectedly. Here we can see the article, which is at the master catalog, has been updated successfully. Let's now see about delete object API. This API is essentially used for performing the same deletion as the REST list API delete. In case many items should be deleted, always use the list API, as delete object API might cause load on the system. The method used here is delete and the URL pattern is /object/entity identifier/entity item. Before firing this delete object API call, let's see the response of this particular item. So this is an item which is available in master catalog. So now let's fire the delete call. So it has given a response of 200 OK, which means the entity item has been deleted successfully. If it's 404 not found, then the entity item has not been found. 403 forbidden if the user does not have the delete permission, and 500 if the server returned an unexpected server error. Now let's fire the same get call. You can see the object is not found. That means the item has been deleted. So that's all from the demo part. For further examples of object API, product documentation can be referred. Let's move on to the summary. The usage of version 1 of Read Object API is supported. However, it's discouraged as an optimized version of Read Object API, which is version 2, is introduced with PIM version 10.5. Kindly refer product documentation service API for any further queries on object API usage. That's all with today's presentation. We would love to hear from you, so kindly contact us on support videos at informatica.com or over Twitter for any further queries. Thank you.